All right, we are now on week 2 of our slope unit. Last week we practiced graphing points because that's going to be an important part of representing relations and showing slope. This week we're going to focus on the fact that slope is considered a rate of change. So as one thing changes, something else changes in a direct relationship to that. So the faster it's changing, we're going to see the steeper the slope will be. We'll notice that if it's going up, that's going to be represented with a positive number. If it's going down, that's going to be considered a negative change. So we're going to just take a closer look at this multiplicative or direct relationship between two items by looking at a couple of examples. This example says her hair grows 2 inches every year. So the two things we have are going to be the number of years. Now that's some really big font there. Let me see if I can make that a little smaller. Nope. Maybe if I highlight it first. There we go. Our number of years and the length of the hair. So we need a starting place. Well, if you were 0 years old, we're going to assume that you may be born without any hair. So your hair is 0 inches long. But after 1 year, how long would we expect the hair to be? Well, if it's growing 2 inches every year, it would have grown 2 inches, and so it would be 2 inches long. After another year, it's going to grow another 2 inches, right? I'm going to keep doing this. 1 more year. Now it's been 3 years, and we've grown 6 inches of hair. So that is this table is showing the relationship between the length of the hair and the number of years that have passed. Well, I can show on my graph these same pieces of data. So that first one says 0, 0. That's our starting point. That's our origin, right? So I'm going to put that. There we go. Grabbed a point. Put that right there at the origin. My next point after 1 year is grown 2 inches. So we're going up 2 inches in 1 year. So there's my point 1, 2. If I go up another 2 inches, there's my point 2, 4. Another 2 inches for the next year, and there's my point 3, 6. And we can see they're starting to form a straight line. We've got that direct relationship. Remember I said it was a multiplicative relationship? Well, if I look here, I can multiply my number of years by 2, and that'll tell me the length of the hair. All right? So there is one example of this rate of change being represented as a multiplicative relationship and forming the slope of this line. Let's look at another one. This one says, I can pay $3 per personal pan pizza. So we're talking about cost and pizzas. This is going to be my number of pizzas. This is going to be my cost. So if I buy just one pizza, how much is that going to cost? Well, it's going to cost $3. It says right there, $3 per personal pan pizza, for one personal pan pizza. So if I buy 2 pizzas, that would now be $6, right? $3 a piece. 3 pizzas, $9. So some of you are probably adding 3 each time. Some of you are probably multiplying. Well, adding the same number over and over again is really just the same thing as multiplying. So it doesn't matter whether you're adding 3 each time or you're taking your number of pizzas and multiplying by 3. It's the same thing. But now I have some points that I can graph. We didn't talk about it, but if I had 0 pizzas, well, that would be $0. They're not going to charge me for nothing. Here's that's going to go up $3 for one pizza. Up another 3 for the second pizza. Up another 3 for the third pizza. And I have my points now. 1, 3, 2, 6, 3, 9. And I could do 4, 12. It just would be hanging off my graph here. And we can see it's forming another straight line. It's going up. It's going up quicker. It's more steep because we had a higher rate of change. It was going up 3 for every 1, where our hair growth was only 2 for every 1 year. Oh, look, I used the same number there, and I don't like using the same number, so let me change that. Let's go up another number. Let's make this 4. So let's say she can walk 4 miles per hour. That's doable. That's just 15 minutes for a mile. So that's doable. 4 miles per hour. Let's make this the number of hours here and our number of miles. So in 1 hour, she would go 4 miles, right? What about 2 hours? 8 miles. 3 hours, 12 miles, and I could keep going. But I can see once again, I'm just adding 4 each time, or I'm multiplying by 4. If she can go 4 miles per hour, that means I can take my number of hours and multiply it by 4, and it'll give me my number of miles. I can graph these again. So 1 hour and 4 miles. I'm going to go over 1 and up 4. And then for each hour I add on, it's going up 4 more miles. So up 4 for every hour. And I can see that once again it's making another straight line, and this one's even steeper because as my rate goes up, the steepness of my line is going up because I'm going up more for every time I go over. All right, what about going down? Let's see what that one would look like. This one says it was 10 degrees Celsius and the temperature dropped 2 degrees each hour. So we have hours and we have our temperature. And we're going to start our base time. We're going to say 0 hours have passed, and they told us that at that time it was 10 degrees Celsius. So that's our starting point. And it's going to drop 2 degrees each hour. So after 1 hour, it's going to have dropped 2 degrees. That means it's going to go down 2 degrees. So if it was at 10, 10 minus 2 is 8. And after another hour, it's going to go down 2 more degrees. So after 2 hours, that's going to be 6. And after 3 hours, it's going to be at 4. Hard to see the multiplicative part on this one because we didn't start with 0, and that's okay. Let's go ahead and look at what it would look like on the graph. So here is my 0 hours. It's starting at 10 degrees. After 1 hour, it's gone down 2 degrees. After 2 hours, it goes down another 2 degrees. And it would keep doing this. And we can see once again it's forming a line. This line looks a little different. 1, because it didn't start at 0. And 2, because this line is coming down. After 5 hours, it would hit 0 degrees Celsius. And after 6 hours, it would be below 0. But we see that our line goes down when we have a negative rate of change, when it's dropping or going down. All right, one more. This one says chips were on sale, 2 bags for $3. So we have not pizzas this time, but chips, and we're looking at their cost. Now this one's a little bit different because it doesn't tell us how much 1 bag of chips is. It tells us how much 2 bags of chips are. So that was 2 bags for $3. So how about I do 4 bags? How much would 4 bags be? $6. About 6 bags. $9. And I could work backwards if I wanted. If I was doing 1 bag, that's half of 2. I would need half of $3. You know, I know at least Food Lion, they have 2 for whatever sales. You just buy 1 of them. It still gives you the sale price. So that would be 1 for $1.50. Let me graph these points. So that was 2 bags. Not sure why it's not letting me grab that point. Fiddles and fiddles. Alright, I'm going to grab a pen and make a point then, since he won't let me grab my point. So I'm going to put one at 2, 3. And every time I buy 2 more bags, it's going to cost $3 more. So every time I go over 2 bags, I'm going to have to go up $3. We can see we're going up $3 for every 2 bags we buy. 0 bags would be $0. And we said 1 bag would be $1.50, so halfway between 1 and 2. And once again, we have a straight line. And I could see it's actually going up 1.5 for every 1 I go over, or going up 3 for every 2 I go over. So it is okay for our rate of change to not be a whole number. You can still represent that on a graph. We'll still notice that it's going up so much for every 1 it goes over. And so we can represent these relationships and see their rate of change using the slope of the line.